7 for standard SCSI and 15 devices per controller for wide SCSI. So that's quite a bit more. And not only does the SCSI bus allow more devices per controller, but it also allows concurrent communication. So let's draw a little picture here. So here's our motherboard, and we're going to chain together some disks. Now, when that chain was IDE disks, like this would be a picture for IDE disks, there was only one transfer allowed over this bus at a time. Either device could use the bus to transfer data to and from the motherboard. Well, with SCSI devices, we can make this chain longer. Not only can we do that, but the devices all can communicate simultaneously to and from the motherboard. Okay, so that's what concurrent communication means. All these devices can be transferring data to and from the motherboard at the exact same time, as long as the sum total of the bandwidth of all those transfers does not exceed the bandwidth of the bus itself. Okay, so you're going to get good performance by chaining SCSI devices together. You're really not going to lose much performance unless you're transferring tons and tons of data simultaneously from all these various disks. Okay, so that's the advantage of SCSI. You can have more devices and you can have this concurrent communication. Now, a problem that some people run into with SCSI sometimes is that they don't terminate the chains correctly. So you've got to terminate the chains, and you've got to terminate them correctly. You've got to lay the chain out so that under any situation it will be terminated correctly. So let's talk more about termination, because that's a very tricky topic, and it typically causes errors that are a little harder to detect than some errors. Okay, so our SCSI interface here, here's like the simplest picture we could have. We've got our SCSI interface and we've got our hard drive. Now the SCSI interface is actually a device on the SCSI chain, so you have to terminate this as well as the hard drive. Both ends of the chain are terminated in this example. So let's say that stuff on this side of our picture here is internal devices, like inside the case of the computer, and stuff over here are external devices. Okay, so now let's add some stuff to this. Let's say we've got our SCSI interface again, and let's say on this side we add a zip disk, an internal zip disk, and then we have our hard disk again. And then outside here I have a scanner, and then over here I've got an external hard disk. Okay, so there's my new SCSI chain here. Now what needs to be terminated are the two hard drives. Not only do the two hard drives need to be terminated, but it really matters how this is laid out in the order here. So when I'm drawing this, this is like a physical drawing, like the SCSI device, the SCSI interface hooks up to the scanner first, and then it's chained to this hard drive. Internally, it's hooked up to the zip disk first, and it's chained to this hard drive. Okay, so that's physically the layout of your computer. All right, and these two must be terminated. But you know, if you flip-flop these two, right? Say you put the hard drive first next to the SCSI interface, and then you put the scanner out here. Well, now it might seem like the scanner needs to be terminated, and it does. But if the scanner's off one day, like you just turn the scanner off or you unplug it or something, then this isn't going to work. Nothing on this chain is going to work, or there's going to be likelihood for failure, because now nothing's terminated on this side because the scanner's turned off. So you should put stuff on the ends of the chain that are always going to be on. Internal stuff is probably always going to be on because it's hooked up to the power supply of the computer, but external stuff is more likely to be turned off. So you have to make sure whatever's on the end, on the external side of things, is something that's going to be on all the time so that the termination works properly. And a hard disk is a good candidate for that if you had an external hard disk. You'd want that on the end because it's always going to be on, so if you have that terminated, everything else in the chain is going to work. All right, so that's a little bit of a tricky issue. There's also how you terminate this. That's another issue. So the termination, there's two choices for termination. Okay, one choice is physical. So you can have these connectors that slide over the end that actually physically terminate the chain. Or another choice is electronic termination. Sometimes this is also called smart termination. And if you read some tech journals, you'll see they spoof on this and call it dumb termination, because a lot of times this doesn't work. So what you want to be careful of is that if you use this, if you depend on this electric termination, that you try out all these various situations before. Turn stuff off on the external side and make sure everything still works properly. Okay? If you have your choice, everything that I've read says you should use physical termination. Those little things that slide over the end that actually physically terminate it. They're just much better. They're much more reliable. And then, of course, you have to lay this out. You have to be smart when you lay this out so that the devices that are always on are on the ends of this chain. Let me just talk about a couple other SCSI issues here that cause problems sometimes. One of them is the assignment of SCSI identification numbers. There's the identification numbers available for standard SCSI are from 0 to 7, so there's 8 identification numbers there, and the SCSI identification numbers for wide SCSI is from 0 to 15, so there's 16 identification numbers there. Now, earlier I told you that you could only hook up 7 devices to standard SCSI and you could chain together 15 devices for wide SCSI, but I just told you there's 8 ID numbers for standard and I said you could hook up 7 devices. Why that one discrepancy? Well, because the SCSI host adapter itself is actually a device on the SCSI chain, and so that takes up an identification number which only leaves 0 to 6 or 7 numbers for the rest of the things to hook up to the chain. So when I said only 7 things could be hooked up here, I was already calculating in that the SCSI host adapter took up one of those identification numbers. All right, so the SCSI host adapter is typically identification number 7, and a boot disk is identification number 0. So this causes people problems sometimes because they think of these numbers being the ends of the chain. So 7 is one end of the chain and 0 is the other end, and so they terminate these devices because they have ID number 0 and ID number 7. But you have to just ignore these numbers when you're thinking about termination. When you're thinking about termination, think about that physical layout and terminate the physical ends of the chain like we just did in the last slide, and then you'll be fine. Don't even think about these identification numbers when you're thinking about termination. They're irrelevant to termination. Okay? Another thing that causes problems is cable length. So the cable length, depending on your variant of SCSI, whether it's like standard or wide, now there's like ultra SCSI and all this stuff, the cable length can range from 1.5 meters to 12 meters. And I thought I saw something recently on the web that was like 25 meters long or something for cable lengths. I couldn't find a reference to that, so I just wrote 12 here. So this could actually end up being the limiting factor to how many devices you hooked up. Like if you only could have a 1.5 meter cable hanging off out of your computer here, you probably can't hook up like 15 devices to that because it would just be hard to get 15 devices all lined up there within 1.5 meters of each other to hook them all together in this 1.5 meter cable. So sometimes this is the limiting factor. You just need to determine for your variant of SCSI how many devices you can hook up practically given the cable length limitation and also these ID limitations. Let's talk a little bit about peripherals and problems you might run into with peripherals on your computer. And when I'm talking about peripherals, I'm talking about anything that hooks up to your computer, like a printer, a scanner, an external zip disk. Even like an internal hard drive is a peripheral. Even though it's inside your computer, that hard disk could easily be an external hard disk outside your computer. I guess all I'm trying to get across here is that it doesn't have to be outside of the case of your computer to be a peripheral. It could be inside. So the problem areas that I've listed here are with the device itself. And in terms of the device itself, I've already given you resources and places to look to determine if a specific brand of device is compatible with Linux. So once you determine that something's compatible with Linux, then you don't have to worry about that compatibility issue anymore. Certainly, like the circuitry in the device could fry, and you need to get the device fixed or replaced or something like that to have a functioning device. But once you get that compatible device, you don't have to worry about compatibility issues anymore. Then there's the cable that hooks the device up to the interface, and if that's faulty or loose, you're going to run into problems. But that's easy enough to test. You can make sure that snug up the ends and see if it works, and if that doesn't work, then replace a cable from some other computer. Put it in here and see if that makes the whole thing work. Then if it does, then you'll know it's that initial cable that was bad. And then there's the interface itself, and we haven't talked too much about that, so let's concentrate on that right now. The floppy interface is built right into the motherboard. Okay, so if that goes bad, then you either have to replace the motherboard, or if you're resourceful, you could find an old 386 or a 486 card, like an ISA card or something, that has a floppy interface on the card. So you can plug the floppy drive into that floppy interface on the card, plug the card into the motherboard of the computer, and now you've got a floppy drive back on your computer again without having to buy a whole new motherboard. So coming across these might be a little bit hard as long as you don't have to pay like antique prices for them, some like collector's item price for them, then it'll be a lot cheaper than buying a new motherboard. And maybe you're saying to yourself, well, I don't even use that floppy drive. What do I need that for if the interface fails? But you need to have something, right? Like when you did the installation process, you created that emergency boot disk on the floppy. So if your hard disk fails, at least you've got some way to boot your system, and the floppy drive is why that is still on your computer to do that in those emergency situations. The monitor port is actually on the video card itself. So you can determine what's wrong here. Like if you don't even see any text when you turn your computer on, you don't even see like the BIOS messages or anything like that, then you know something's seriously wrong. And you know, it's maybe the device is fried, or maybe the cable's bad, or maybe it's the interface. So you can easily take the cable and the device